Okay, today we're going to do this a little differently. Today I'm going to talk and explain things a bit. First of all, here's what we're building. This is most likely the paint scheme the model's going to use. So I just finished building that yesterday, so I had to show it off. Now, what we're looking at is the tailwheel mechanism. What I tried to do was to replicate the scale tailwheel as much as possible without making it too complicated. As you can see, it's fairly close. Now, one of the things that's interesting is the steering mechanism. That's always a problem with the 190. The full-scale plane had a thimble and a centering spring on the top, as you can see in the center of the screen there. So what I ended up doing is I actually used this setup on my larger Focke-Wulf a few years ago. I used that thimble and put it on an arm like a little tiller, and then use it to move the steering of the tailwheel. So you can see how it moves back and forth. And I wasn't sure about how it would work on the first 190, but it did actually work pretty good. So I tried it on this one, and so far it looks pretty good. Now, another thing I'm looking for is trying to replicate the movement of the retraction and also the compression of the oleo strut, the same as the full scale. So here's the strut in the fully extended position. So as the plane's coming into land, this is the way it would be. Now, when the plane's sitting on the ground, I'll pull those antennas off before I break them. The wheel would be compressed with the weight of the aircraft on it. So that would actually look somewhat like that. So when the plane's sitting on the ground, that's roughly the position of the tail wheel. So the mechanism itself uses a track that runs up through the fin, and then it's operated by cables. I ended up using 100-pound test cables. A couple of the guys on RCSB suggested using Kevlar instead of steel cables, and I have to say I'm very happy with the way it works. So let's see if we can make the tail wheel work. Okay, there's the bottoms of it. And then here we'll look at the top. Okay, that's pretty much the operation of it. The rudder I can show you here too while we're in here. That uses pull cables, and I did the end of the cables to try to replicate the push rods of the full scale as much as I could. Another point of interest is the pulleys. These are machined aluminum pulleys, and I went with a little larger diameter pulley to make a smooth transition for the cables. And then the top pulley. Now, one of the other things I needed to do is the steering cable for the tail wheel. The way I have the geometry set up, it needs to go slack when the tail wheel is retracted. This also keeps the tail wheel from turning. So what I did is I put the steering servo on slides and connected it to the actuator. So as the actuator retracts the gear, it allows the servo to move rearward. So that takes care of that part of the function. And that also seems to be working quite well. Another little detail is the pulleys for the rudder cables. I wanted to run the cables up along the spine of the plane, but I still needed to clear all of the other parts. So we've got those pulleys, and these transition the cable down to where I need to get it for the servo. Okay, so now let's see if we can turn the fuselage over. Guess I could probably use a helper. Okay, so here now you can see the setup of the actuator. Here's the tail wheel steering servo, the rudder servo. You can see the cables coming up through the pulleys. And then what I did is I put a bell crank forward of it, so all the tension on the cables is handled by that bell crank, and then the servo just moves the bell crank. And I'm trying some different actuators this time. These are made by a company called Actuonics up in Canada. This one is a much larger actuator than the tailwheel actually needs, but this configuration works really well. This slide made it very easy to connect all the cables. And then steering servo. You can see how that push rod pulls it forward again. And then the forward end. And that's pretty much it.